You're interested to listen? Yes, okay. So, can you clap once? Okay, so, do you notice any difference before clapping your hands and after clapping your hands? What difference do you notice? Yeah, some sound is produced before clapping your hands and after clapping your hands. So today my topic is also sound. Sound. In our daily life, we hear so many sounds. Some sounds are presentive, some sounds are noiseful to us. But anyway, even they are presentive or they are noiseful, we are hearing them, and you can produce the sound also. For example, when we talk, when we speak to a person, while we move a heavy body on the surface because of friction, the TV produces sound. So all of these examples tells you that the sound is everywhere. The sound is unavoidable and integral part of our life. It's almost the omnipresent. While I switch on the audio player, it produces the sound. How do we communicate with each other? Yeah, some sound is produced. We need some sound to communicate with each other. So sound is everywhere. I think you all know about two types of communication. Verbal communication and non-verbal communication. Verbal communication means by speak, by talk, oral communication, like how I'm communicating to you. And the non-verbal communication means by writing, by written, I'm writing something. So this is called non-verbal communication. But 80% of all we do verbal communication, means we speak, we talk, and we communicate. So we do verbal communication. And now here the very important that what is the physics behind the sound? Do we have any other machine which produces the sound or which takes the sound and helps us to understand? So all of this we understand. So if we go to the open theaters, there are big loudspeakers. So everywhere around that we can hear the sound. And everybody are using mics. They produce a sound. So all this example tells that the sound we are producing. What is sound? The sound is an energy content. Yes, it's an energy. Like the solar energy, like the wind energy, like the electrical energy, the magnetic energy is an energy. Just like the sound is an energy. And just like the light is an energy, that's how the sound is also an energy. And here, if we start speaking here at one point, the sound travels to some distance. For example, I start speaking here at point A, and here there is a person who is receiving my voice at point B. The sound travels from this point to this point in this direction. So here, what the symbols are called, what this semicircle are called? These are called waveform. Wave, yeah. These are called waveform. Initially, I have informed that the sound is an energy. But now I am saying that the sound is a wave. What is this? The sound is an energy as well as wave? Yes, the sound is an energy as well as wave. How? How it is possible? See, I will explain. The scientist wanted to show to all the people how the sound looks. But here you can't see the sound. You just experience the sound. So, but they understood that a sound can break a glass. A sound can move a body. How? A sound can break a glass. A sound can move a body. The only possible that the sound has energy. So we clear that the sound has energy. But now the question here is, how do you show that energy on the board? How do you experience that energy to all the people? So that's why the scientist makes a pictorial representation to show all the people that how the sound looks. So the wave is a pictorial representation of energy. Okay? And when a physicist understood that the sound travels, the wave is in sinusoidal form. Sinusoidal form means it's be in this way. It's your origin O. Or it's be in this way. So this is your sinusoidal form. The wave is in this form. Okay? So a body is producing sound. Okay? At which point it starts producing, it stops producing sound? For example, see, I'm dropping this, okay? Some sound is produced. When it stops producing sound, until it's vibrating, it produces the sound. When the vibration stops, the sound produced by it also stops. Here we clear that the vibration in your body produces sound. And the sound produces vibration also. For example, I'm speaking now, I'm communicating to you. So my body is vibrating if I touch here. Or my body is, so here we clear that the sound produces vibrations. And in this scales example, we have cleared that the vibration produces sound. And if I touch a body when it is producing sound, my body is vibrating. So we clear that the sound produces vibrations and vibrations produces sound. Okay? And here, I'm talking. Okay, how do you able to hear? By using which organ you are able to hear?
Ear.
Yes, yeah. Ear plays an important role to hear the sound. So let us peep into our ear and try to understand how we hear the sound. Okay? So see this. The pinna of the external ear collects the sound vibrations, and it reaches the middle ear. And in the middle, we have learned that the sound travels in the form of vibration. So this vibration strike the middle ear. I mean the eardrum, and makes it to vibrate. The vibrations from the eardrum reach the middle ear, and the middle ear consists of three bones: the malleus, anvil, and the stapes. They magnify the sound vibrations, and from this middle ear, the sound reaches to the ear cochlea. Yeah, it reaches the cochlea. The cochlea is filled with the thick fluid particles. The vibrations in the cochlea, the motion of the vibrations in the cochlea are detected by the tiny hair, which are connected to the nerve at that point. So, this formed as electrical signals, and it transformed these are the nerves which are connected to our head. So this acts as the electrical signals. This travels the messages by the nerves to the brain. So this how we hear the sound. So here there are two types of sound: feeble sound and loud sound. If I tap this board loudly, I got the loud sound. But if I tap this board gently, I got some feeble sound. So why some sounds are feeble and why some sounds are loud? The amplitude plays an important role in this the forms of vibrations. Amplitude means the maximum displacement of a vibrating body from one place to another. I mean its mean position. It's called an amplitude. And the frequency means the number of vibrations per second is called frequency. So here, what's its amplitude? Here the amplitude is 3 to 4 centimeter. From here to there. Okay? The amplitude. We have completed the amplitude, we have completed the frequency, and now we are moving to the pitch. The shrillness of the sound is known as pitch. Okay? The pitch is more in the women when compared to the men. Okay? When I'm speaking, okay? By using which part I am able to produce the sound? Vocal cords. And the larynx are the most important part in the humans to produce the sound. It contains two muscular ligaments which are called vocal cords. With the help of vocal cords, I am producing some sound. And there is a narrow slit inside which allow the passage of air. Our vocal cords are closed when we speak. Now I am speaking now. My vocal cords are closed. The vocal cords are open during breathing to allow the passage of air into the lungs. So vocal cords plays an important role to speak. Okay, we have completed this. Okay, now I'm speaking and you are hearing. I'm speaking because by use my vocal cords, and you're hearing you are hearing by use your ears. How do you hear? Because of your ears. The sound travels from here to you, okay, and reaches you. How it travels? It travels like a wave through a medium. There is medium. Okay, there is medium through the sound is traveling. Here only the medium is there. If we go in the universe, there is no medium. There is vacuum. In the vacuum, the sound doesn't travel. If we see in the TV channels, there is we see like the big planets are crashing together or the meteors are blasting, then a big sound will come now. But in reality, nothing like that. Nothing is like that. In the universe, there is no vacuum. Then how the sound travels? How we can able to hear the sound? So in the universe, there is no medium. There is vacuum. For example, in the universe, the explosion of the sun, explosions in the sun takes place, but we are not able to hear the sound. Why? Because for the transmission of the explosions from the sun to the earth, we need some medium. But in the transmission of explosions from earth to sun, at some distance there is no medium, there is vacuum, and in the vacuum the sound doesn't travel, so we are not able to hear the explosions happening in the sun also. I said that some sounds are feeble and some sounds are loud. Okay, the feeble sound. Feeble means with no energy, with weak sound, poor sound. Okay, then there are two types of sounds. First, the audible range that we can hear is before up to 20 hertz and less than 20,000 hertz. The inaudible range is less than 20 hertz and greater than 20,000 hertz. The intensity of total silent is 0 decibels. If we hear such sounds which are inaudible to our ear, we have so much harmful to our, which causes the harmful effects to our body. So one of the harmful effect is hypertension, sleeplessness, and the increase in the blood pressure. Okay, that's it. And it's depend on you. So I talk about 15 to 10 minutes, I think. It depend on you to decide whether my class is normal. I mean, my class is a good transformation of information or it's a noise pollution. Okay, thank you.